Hello everyone. Let's talk about the chemical kinetics multiple choice questions. This is step-by-step guide to problem solving in chemical kinetics. Question number 1. Given the reaction 2 moles of NO plus O2. The product is 2 moles of NO2. The rate equation is given. Rate is equal rate constant times NO concentration squared times O2 concentration. What is the unit of the rate constant? K. If the rate is measured in molar per second. First, let's write the rate law and then apply the units. Rate is measured in molar per second and each concentration term measured in molar units. We can cancel the similar units in numerator and the denominator and then clean up the equation. The rate constant units is molar per squared times per second. Question number 2. For the first order reaction, A goes to B. The half-life is 10 minutes. What is the rate constant K for this reaction? First order half-life equation is ln2 divided by K. ln2 value is 0.693 divided by K. Then after we rearrange, K value is 0.693 divided by 10. It is 0.0693 per minute. Question number 3. For the reaction A plus B goes to C. The rate equation is given. Rate is equal rate constant times A concentration squared B concentration. If the concentration A doubled, the concentration B halved, how does the reaction rate change? Let's write the initial rate and the final rate, two equations. The initially rate 1 is equal A concentration squared times B concentration. And after we change A concentration and B concentration, the new rate is rate 2. A concentration doubled, then 2 times A. B concentration halved, that is B divided by 2. Now let's divide rate 1 equation by rate 2 equation. Cancel the similar terms in numerator and the denominator. And finally we can get the connection between rate 1 and rate 2. Rate 2, the new rate is equal to 2 times rate 1. That is, the rate has doubled. Question number 4. Which of the following statements is true for a reaction at equilibrium? Equilibrium is in a chemical reactions when forward reaction rate is equal to the reverse reaction rate. We call the reaction is at equilibrium. The equilibrium is a dynamic process. The reaction is going on forward and the reverse direction. Concentration of the reactants and the products. No net change. They are at the equilibrium. So according to the given answers, the rates of the forward and the reverse reactions are equal at the equilibrium. Question number 5. For the reaction 2A goes to B, the initial concentration of A is 1.0 molar. After 10 minutes, the concentration of A is 0.5. Concentration become half. Assuming the reaction is first order in A, what is the rate constant K? So if this is first order rate equation is ln A concentration at time t is equal minus K times t plus ln A concentration at time 0 at the beginning. So if you apply the values, A concentration after 10 minutes is 0.5 minus K rate constant and t time taken 10 minutes plus initial concentration 1.0. Then after you solve this, you can see K value rate constant is 0.0693. Question number 6. An increase in the temperature of the reactants causes an increase in the rate of reaction. How we can explain this? Increasing the reaction temperature increase the reaction rate. At higher temperature, molecules move faster because they have more kinetic energy. As a result, the frequency of collisions increases. Therefore, when temperature rises, a large proportion of molecules have enough energy to overcome the activation energy barrier. They are also leading to more successful collisions. Therefore, reaction rate increases. The decomposition of hydrogen peroxide H2O2 is catalyzed by iodide ions. Which of the following best explains? So here we need to know what is the role of the catalyst. A catalyst is a substance that increases the rate of the chemical reaction, but without being consumed in the reaction. Small amount of catalyst is enough even for large-scale production. How the catalyst can increase speed of the reaction? Catalyst can provide alternate path for the reaction that has lower activation energy barrier. Lower activation energy barrier paths speed up the reaction, increase the reaction rate. So among these given answers, the best answer should be it decrease the activation energy barrier. How about the enthalpy change, delta H? Catalyst does not affect on delta H or enthalpy change. A reactant energy level and the product energy level stays the same. The only effect on the catalyst is on EA, activation energy. Question number 8. Which of the following reactions has the highest reaction rate at room temperature? This is a Arrhenius equation. ln K is equal ln A minus EA over RT. Lower activation energy means large proportion of the reactant molecules have enough energy to overcome the activation energy barrier. Therefore, the higher reaction rate. High frequency factor. Frequency factor is this is uppercase A. That indicates there are more collisions with the correct orientation and sufficient energy. That leads to a successful reaction. It increases the reaction rate. So lower activation energy and high frequency factor increase the reaction rate. Question number 9. Higher the activation energy, slower the reaction step. Lower activation energy barrier means faster that reaction step. In a reaction mechanism, the step with highest activation energy meaning is that is slowest step. The slower step should be the rate determining step in that reaction mechanism. For a reaction with rate low, rate is equal rate constant times A concentration times B concentration. What happens to the rate if the concentration of A tripled and the concentration of B doubled? So let's write two equations, rate 1 and then rate 2. This is rate 1, concentrations A and B, and after we triple and double the concentrations, A become 3A, B become 2B, that is rate 2. So if we divide rate 1 by rate 2 and clean up the equation, we can see rate 2, the new rate, is equal 6 times the previous rate. Rate has increased 6 times. For the reaction A plus B goes to C. Again, doubling the concentration of A quadruples the rate of reaction, while doubling the concentration of B doubles the rate. Now we need to determine what is the rate law for this reaction. When A double, quadruple the rate of reaction, then what is the order with respect to A concentration? The order of A should be 2, because A double, the rate quadruple, become 4 times, then it should be A squared. When B double, double the rate of the reaction as well, then it should be B to the power 1. The same effect on the rate. Then the rate law equation should be rate is equal rate constant times A concentration squared times B concentration. Powers should be second order in terms of A and first order in terms of B. Question number 12. Which of the following factors does not affect on the rate of a chemical reaction? There are many factors that affects on reaction rate. The first one is temperature. Second, concentration of the reactants. Another factor is surface area of the solid reactants. So increasing the temperature can increase the reaction rate. Increasing the concentration again increase the reaction rate. Increasing the surface area also increase the reaction rate. And another factor is catalyst. If we add a catalyst, again it can increase the reaction rate. However, the last one, the equilibrium constant of the reaction, it's no effect on the reaction rate. Question 13. For the reaction A goes to B, the rate law is given by rate is equal K times A concentration. Rate constant is equal 0.21 per second. What is the half-life? This is first order reaction because the K is given in per second units. The per second units rate constant is for first order reaction. Now for the first order reaction half-life equation is 0.693 divided by K. Then T half is equal 0.693 divided by 0.1, it is 6.93 seconds. Question 14. Which of the following statements about catalyst is true? The catalyst increases the reaction rate because they can provide the alternate path, the low activation energy path for the reaction. And catalyst not consumed in the reaction. They can recover at the end. And small amount of the catalyst is enough for a reaction, and catalyst does not affect on the equilibrium position. Next, for a reaction with the rate low, rate is equal K times A concentration square. What happens to the rate if the concentration of A is halved? Again, we can write that initially reaction rate and then finally after change the A concentration become half, rate is equal rate 2. So if you divide rate 1 by rate 2 and after cleanup you can see rate 2, the new rate is equal 1/4 of rate 1. That means the rate is quartered. Question number 16. For a second order reaction with the rate low, rate is equal rate constant times A concentration times B concentration. Which of the following graphs would yield a straight line? There are four answers given: A concentration versus time, or ln A concentration versus time, or 1 over A concentration of A versus time, or A times B concentration versus time. Now let's see what is the second order rate equation looks like. The second order rate equation is 1 over A concentration at time t is equal K times t plus 1 over A concentration at the beginning at time 0. This is y is equal mx plus c type equation. If we plot 1 over A concentration at time t on the y-axis and time on the x-axis, we can see a positive slope of the line. Slope of the line gives the rate constant k. Now, according to the given answers, the answer should be 1 over A concentration versus time should be the second order reaction that yield the linear plot. Next question. If the activation energy of the reaction is 75 kilojoules per mole and the temperature increased from 300 Kelvin to 310 Kelvin, which of the following best describes the effects on rate constant K? This is the Arrhenius equation after we rearrange for two different temperature values. And let's apply the values. ln K1 divided by K2 is equal EA. EA is activation energy. It's given in the question 75. So 75 kilojoules is 75,000 in joules divided by the R value 8.314 joules per mole per Kelvin times T1 is 300, T2 is 310. So after you solve this, you can see K2 and K1 values connection. K2 is equal to 2.6 times K1. That is the rate constant. K2 is increased than the previous rate constant K1 more than 2 times. Among the given answers, the rate constant more than doubles is the best answer. Next question. The decomposition of N2O5, this is dinitrogen pentoxide, follows the first order kinetics. If the rate constant is 4.8 times 10 to the negative 3 per second, what is the half-life? First order half-life equation is T half is equal ln2 divided by K. ln2 value is 0.693 divided by the K value is 4.8 times 10 to the negative 3 per seconds. Then half-life is 1.4 times 10 to the power 2 seconds. Question number 19. The rate law for the reaction is rate is equal rate constant times A concentration times B concentration. You can see in this given rate law, order in terms of A is 1 and order in terms of B is 1. Now the question is, if the concentration of A is doubled while the concentration of B remain constant, how does the rate change? Then rate is proportional to the A concentration. That is, order of A is 1. When A concentration double, the rate also double. Question number 20. In the reaction, 2 moles of NO plus 1 mole of O2 produce 2 moles of NO2. So the rate law is rate is equal rate constant times NO concentration. Order is 2 times oxygen concentration. Order is 1. If the initial concentration of NO is 0.2 molar and O2 is 0.1 molar and the rate constant is 1.0 molar per squared times per second, what is the initial rate of the reaction? The rate equation, and then if we apply the values, K value is 1.0 and NO concentration 0.2 and oxygen concentration 0.1. So after you solve this, the rate should be 0.004 molar per second. Question 21. Which of the following statements is true for zero order reaction? Zero order reaction, rate is equal rate constant. The reason is A concentration, the reactant concentration to the power 0. Then it becomes 1, the rate is become rate constant. The rate is independent from the reactant concentration. Among these given answers, the first answer is the best. The rate is independent of the concentration of the reactants. Next question. For the reaction 2A plus B goes to C plus D, the rate law is found to be rate is equal rate constant K times A concentration. Power is 1 times B concentration square. What is the overall order of this reaction? The overall order means if you add the orders of A and B together, that is overall order is third order. Which of the following changes would alter the rate constant K for the reaction? Rate constant K depends only on the temperature and it is independent from the other factors like reactant concentration. A reaction has the activation energy 50 kilojoules per mole and the rate for that reaction is 1.0 times 10 to the negative 3 molar per second at 298 Kelvin. Using the Arrhenius equation, we need to calculate how would the rate change if the temperature increased from 298 Kelvin to 308 Kelvin. So let's apply the Arrhenius equation. This is Arrhenius equation for two different temperature values. Let's apply the values. The EA values 50 kilojoules per mole become 50,000 if we convert into joules. divided by R value times T1 minus T2. T1 is 298, T2 is 308. Then the K2 value is 1.926 times 10 to the negative 3. So initially K1 value is 1 times 10 to the negative 3. It has doubled. The rate constant has doubled with increasing temperature. So the rate should also be doubled. So the answer is rate would increase by factor of approximately 2. Let's talk about question 25. The decomposition of hydrogen peroxide is first order reaction with rate constant is 1.0 times 10 to the negative 2 per minute. How long will it take for the concentration of hydrogen peroxide to decrease to 25% of its initial value? If you have a question like this, you can assume that the initially concentration is 100% and it decreased to 25%, meaning is 75% consumed in the reaction. So let's apply first order rate equation. It is Ln concentration of the reactant at time t. So finally concentration decreased to 25, meaning is 25 is our final concentration, is equal minus K times T plus Ln initial concentration. So initially we assume it is 100. After you solve this, you can see the T value, the time taken to the concentration decreased to 25 is 138.6 minutes. Next question. The city's water supply is contaminated with a toxin. Initially, the concentration of the toxin in water is 0.63 milligrams per liter. Fortunately, this toxin decomposes to safer mixture of products by first order kinetics with rate constant 0.27 per day. How long will it take for half of the toxin to decompose? Half of the toxin means initially 0.63, so final concentration should be 0.63 divided by 2, the half of that. Let's apply the first order rate equation. Final concentration, the toxin concentration at time t, the half of the initial value, 0.63 divided by 2 is 0.315, is equal rate constant negative 0.27 per day times T plus Ln initial concentration 0.63. Again, after you solve this, you can see the time taken to the initial toxin level to become half of its value is 2.6 days. Question 27. For a reaction mechanism with slow initial step, which of the following is true? The reaction mechanism contains the series of steps. The step with highest activation energy is the slowest step. The slowest step is the rate determining step in a given reaction mechanism. So in this reaction mechanism, the rate law is determined by this slowest step or rate determining step. The answer is answer A. The rate law is determined by the initial step. Question number 28. What is the slope of Arrhenius plot for the following reaction? So you have answers given and the data given for rate constant and the temperature. I have added here another two columns extra. If we have rate constant given, we can find out ln K and the temperature 1 over T values. The reason is Arrhenius equation is ln K is equal ln A minus EA over RT. If we linearize this equation, the linear equation looks like this. ln K is equal minus EA over R times 1 over T plus ln A. You can see this is y is equal mx plus c type equation. So if you plot ln K in the y-axis and 1 over T in the x-axis, we can get the linear plot with the negative slope of minus EA over R. Now let's calculate the slope of the line. The slope of the line, if you pick any 2 points, slope is equal delta y divided by delta x. We don't have to draw the graph here. Just by looking at the data given, calculate the slope of the line. I'm going to pick two data points in ln k and 1 over t columns. So I picked 2.79 and 7.32, the first and the last readings. And then delta y is y2 minus y1 divided by x2 minus x1. Then you can easily calculate the slope of the line. It is negative 1.22 times 10 to the power 4. Question 29. For the chemical reaction system described by the diagram below, which statement is true? You can see exothermic reaction is given. The forward reaction, reactant goes to the products. Activation energy marked in green color. It is exothermic and EA is small. Let's consider the reverse reaction. Reverse reaction, products goes to the reactants. Reverse reaction is endothermic and EA is indicated in purple color. It is larger than the forward reaction. Now in the given statements, the activation energy for the reverse reaction is greater than the activation energy of the forward reaction. Question 30. For the chemical reaction system described by the diagram, which statement is true? Again, this diagram is given for exothermic reaction. Reactant goes to the products. The green color arrow indicated activation energy. It is 25 kilojoules per mole. And purple color arrow is delta H, enthalpy change. That is product energy minus reactant energy is negative 95 kilojoules per mole. So here products at lower energy, reactants at high energy. Product energy minus reactant energy is negative 95. The other way, if you consider this gap between reactants and the product energy, the gap should be 95 kilojoules per mole. Now the question is, what is the activation energy for the reverse reaction? The reverse reaction goes products towards the reactants. Activation energy for the reverse reaction is energy difference between product energy to the mountain top. Then we need to get the gap between the P and transition state, the peak top. It should be 95 plus 25. Both of you need to add together. The total distance, it is 25 plus 95. The answer is 120 kilojoules per mole. The half-life of second order reaction depends on, there are four answers given. T half for the second order reaction is equal A concentration divided by 2 times rate constant. The answer should be both the rate constant K and the initial concentration of the reactants affects on the half-life for the second order reaction. Question 32. It takes 42 minutes for the concentration of reactant in first order reaction to drop from 0.45 to 0.32 at 25 degrees Celsius. How long will it take for the reaction to be 90% complete? There are two steps here. First step is applying the first order rate equation. You need to calculate rate constant first. This is the first order equation. So if we apply the values, Ln, the final concentration is 0.32 is equal minus rate constant times time taken is 42 minutes plus Ln initial concentration is 0.45. After you solve this, you can see rate constant is equal 8.12 times 10 to the negative 3. Now let's apply this for again the first order equation. 90% completion. 90% complete means the remaining concentration. If we assume 100% is the initial concentration, 90% complete is only 10% remaining. Then the final concentration, we can assume that 10, ln 10 is equal, rate constant we already calculated, 8.12 times 10 to the negative 3 times time taken t plus ln initial concentration 100. Now after you solve this, you can see the time taken for 100 become 10 or 90% completion, 284 minutes. Another way you can solve this, 90% completion, you can assume that initially 1 and then remaining is 0.1. Again it is 90% completion, 0.9 completed. Question 33. The certain first order reaction A goes to B is 25% complete in 42 minutes. What is the half-life of the reaction? Again the same way, let's apply the equation for 25% complete. That means 75% is the remaining concentration. Ln final concentration 75, or if you want you can apply 0.75 is equal minus K times 42 minutes plus initial concentration. If we assume 75 here, it should be 100. Or if we apply 0.75, it should be ln 1. So after you solve this, you can calculate the rate constant K, 6.86 times 10 to the negative 3. We need to calculate the half-life for this reaction. If this is first order, T half is equal 0.693 divided by K. 0.693 divided by 6.86 times 10 to the negative 3. Then T half is 101 minutes. Question 34. Ammonium ion NH4 plus react with nitrite ion NO2 minus to yield nitrogen gas and liquid water. The following initial rates of reaction have been measured for the given reactant concentration. You can see here there are 3 trials, experiment number 1, experiment 2 and 3, and then ammonium plus concentration and NO2 minus concentrations at each trial is given. The initial rates given in molar per hour units. Now you need to determine which of the following is the rate law for this reaction. There are 5 answers given. Let's calculate the order of ammonium plus ion and the order of NO2 minus ion. We can write the equation, rate equation. Rate is equal rate constant times. Assume the order with respect to ammonium plus is X and order in terms of NO2 minus is Y. Then let's pick experiment 1 values. Initial rate is 0.02 times rate constant times ammonium plus concentration, and experiment 1 is 0.010 times X times experiment 1 NO2 minus 0.02 to the power Y. That is our equation 1. So the same way for row number 2 and this third row, let's write two another equations. The initial rate is equal rate constant times ammonium concentration to the power X times NO2 minus concentration to the power Y. For the third experiment, initial rate is equal rate constant times ammonium plus concentration times NO2 minus concentration. Now we have 3 equations. Let's pick equation 2 and 1. If we divide equation 2 by 1, you can see the 0.02 is common to equation 1 and 2. That is NO2 minus concentration same. So we can remove the NO2 minus concentration. They cancel each other after we divide 2 by 1. Then the remaining is 2 initial rates is equal ammonium concentration 0.015 divided by 0.010 to the power X. After we solve this, we can see X value should be 1. That is, order in terms of ammonium concentration should be 1. Let's make equation 3 and 2 now. So if you divide equation 3 by 2, and x value we already calculated 1, then let's divide both the equations. And then you can see 0.5 is equal 2 times 0.5 to the power y. The y value after we solve step by step, y is equal to. The order in terms of NO2 minus concentration is 2. Then the rate law should be the rate is equal rate constant times ammonium concentration. Order is 1. NO2 minus concentration, order is 2. Let's move on to our last question. Similar to the previous one, what is the rate law for the following reaction? The reaction is given A plus 2 moles of B and products are C plus D. A concentration and B concentrations given in 3 experiments and their initial rates. Now what is the rate law for this reaction? We can assume that the order in terms of A is X and order for B concentration is Y. Let's find out what are these orders X and Y. We can write 3 equations like we did in the previous example. For first experiment, first row in the table, initial rate 0.085 is equal rate constant times A concentration power X, B concentration power Y. Same way for the second row, initial rate is equal rate constant times A concentration to the power X, B concentration to the power Y. For the third row, now we have 3 equations. Let's divide equation 2 by 1. If you divide equation 2 by 1, A concentration is common, 0.05 in second row and the first row. So we can easily remove that. And then we can solve for Y, the order in terms of B. So Y order is 1. That is B concentration to the power 1. Now let's make equation 3 and 1. If you divide equation 3 by equation 1, you already calculated the Y value, then X value should be, after you solve this, X is equal again 1. Orders of A and B concentrations both 1. The overall order second order. Then we can write the rate equation. Rate is equal rate constant times A concentration to the power 1 times B concentration to the power 1. I hope now you will have a good understanding about multiple choice questions in chemical kinetics section. If you found this helpful, subscribe to the channel for more learning. Thank you all for watching.